Okay, this is exam 2 for physics 101. First, we have projectile motion, and a ball is thrown into the air at an angle of 30 degrees to the ground. So I have this ball, it goes up, comes down like this. This angle is 30 degrees, and the initial speed is 40 meters per second. I don't know how long does it take to get up to the top height. So first, I need to find v naught y. That's going to be equal to 40 sine of 30. 40 meters per second times the sine of 30, and that's equal to 20 meters per second. And then I know at the top of the trajectory that Vy is equal to 0. I know that Vy, which is 0, is equal to V naught y plus AT. That's 0 equals 20 minus 10 times t, so t is equal to 2 seconds. All right, so the answer is C. What is a horizontal range? Well, I know horizontal range is equal to V naught x times t. V naught x, which is also equal to Vx, that's equal to V naught cosine theta, which is 40 times cosine of what was the angle 30. So cosine 30 is 0.86, and 40 times 0.86 is 34 meters per second. And we had t top is 2 seconds, so t total is twice that, or 4 seconds. So now we come to x, we get 34 times 4, which is 120, 136. That's going to be A for 2. What is the x component of the velocity? Let's see, we have that right here, 34, let's see, 30. Actually, if you keep your proper sig figs throughout and do this in your calculator, you get that it's 34.6. So that's 35 meters per second. Sorry for that. That was a little shady on my part. 2 shells are fired simultaneously from the same battleship at 2 targets. They follow the trajectory shown here. Which of the statements must be true? Okay, they have different angles. They have to have different angles in order to take these trajectories. They don't necessarily have to have different speeds. They can still have the same speeds, just at different angles. And shell number 1 is in flight for more time than shell number 2. That's not true either. So looks like just 1, so D is the right answer for 4. For the two-dimensional motion of a projectile that begins and ends at the same height, all of these apply except which of these? Which of these is not true? The y component of the velocity changes direction during flight. That is true, so we're okay. Remember, with our y motion, our y motion starts out big, and in the positive direction it gets smaller, it goes to 0, and then it goes negative. So our y velocity does change direction. The y component of the acceleration is always negative. That's right, ay is equal to minus 10 meters per second squared. The maximum speed is at the top of the trajectory. That's not true, because Vy is equal to 0. It's at its minimum. Vx is still in the same direction and with the same magnitude, but there's no y component. So the maximum speed is actually minimum at the top. And the time in flight is determined by the y component of the velocity. That is true. At least it's partly true. So the larger the y component of your velocity, then the more time in flight. Actually, not even partly true. That's completely true, because that's dependent upon the angle. And the larger your angle, the larger your y component, the more time your object is in flight. You hit a ball horizontally from the top of a cliff that is 20 meters tall. It's going to look something like this. This distance is 20 meters. What is the horizontal range of the ball? It initially has a speed of 5 meters per second. First, you want to find t. In order to find t, you say y is equal to v naught yt plus 1/2 ay t squared. Because it's horizontal, v naught y is equal to 0, so this term goes away. I get negative 20, because I start at 0, and I go down 20 meters, equals half of negative 10, that's negative 5, t squared. T is equal to the square root of 4, that's equal to 2 seconds. It takes 2 seconds to go from here down to here. Now, what is x? Well, x is equal to vx times t. Vx is equal to v naught x. It has an initial velocity that's all in the x direction of 5 meters per second times 2 seconds. That's 10 meters. So 6 is A. Which of these plots represents the y position for an object launched horizontally from the top of a cliff, just like we had before? Which of these represents the y position? Well, you can think of this in a couple different ways. First of all, y starts big and then gets small. So that gets rid of these two because these both start at ground level. So it has to be b or c. And then we look at the slope. Does the y velocity start out big or small? If it's big, then it should be this one. If it's small, it should be this one. See how the slope is small here. So the y velocity starts out actually at 0. So C is the right answer for number 7. Drop a package from a plane flying at constant speed in a straight line. Without air resistance, the package will which of these? Okay, so this is exactly like what we had in the concept test. You drop a package. This package will follow a projectile path like this, and the plane will continue on such that when the package hits the ground, the plane is directly overhead. So also at every point, the plane and the package are in line. So it is remain vertically. Number 8 is B. From the same height and the same time, one ball is dropped and another ball is fired. Which will hit the ground first? Okay, similar. So I have two balls, one is dropped, one is fired. They both fall to the ground. They will hit the ground at exactly the same time. So C is the right answer for number 9. Which of these statements is true for an object in projectile motion? The x component of the velocity does not change. Hey, that's true. Ax is equal to 0. If the y component of the velocity is 0 at the top of the trajectory, that's also true. The velocity is greatest at the beginning of the trajectory. That's true too, because the y component of the velocity is greatest at that point. And the acceleration in the y direction at the top of the trajectory is 0. No, the acceleration in the y direction is always minus 10. So we have 1, 2, and 3. You fire a ball with an initial speed 20 at an angle of 30, lands at a table 26 meters from the original position. What is the height of this table? So I have an object that I fire like this, but it lands at some height. And we don't know what that height is, but I want to know what is y. Okay, this is a one-step problem. Y is equal to v0 yt plus 1/2 ayt squared. V0 y is 20 cosine 30. Excuse me, v0 y is 20 sine of 30 times t, which is 1.5 seconds. This problem's easier because it has the time. Half of ay is minus 5 times 1.5 squared. 20 sine of 30, that's 10, so it's times 1.5 is 15, plus 5 times 1.5 squared. So it's minus 11 and a quarter. 3.75 or 4 meters. So number 11 is D. Two objects A and B experience the same acceleration. However, object A has twice the mass of object B. So object A, object B. But object A has twice the mass. However, they both accelerate at the same rate. You know what? You're going to need twice the force on object A than you will on object B because F is equal to m times A. They both accelerate at the same rate, but the mass is bigger for object A, so the force has to be bigger by the same amount. So the force on object A is twice the force on object B. Which is larger, gravitational force exerted by the moon on the Earth, or vice versa, the moon on the Earth? Because of Newton's third law and the Newton's universal law of gravitation, both of these are the same. So 1 and 2 are the same. An object slides to the right on a horizontal surface. Which of these is true about the frictional force? Well, the object is sliding in this direction. So the frictional force is to the left. The frictional force is only dependent on the weight of the object. That's not true. It's also dependent upon the surface. The frictional force would decrease if the mass of the object was less. That's true because then your normal force would decrease. And then the frictional force is dependent upon the speed of the object. That's not true. So E is the right answer. Hockey puck slides at ice at a constant velocity. What is the net force? Well, constant velocity, that means A is equal to 0. Since the net force is equal to the mass times the acceleration, that means the net force is 0. Anti-lock brakes keep the car wheels from locking up when you stop your car. Why does this help slow the car down? Okay, so it's because mu s is bigger than mu k, and static friction is better. So C is the right answer. That was straight from the concept test. You push an object of mass m with a force F and cause the object to reach the speed v in a certain time. If you apply the same force to an object with half m, what velocity will it reach? Well, if I have half m, since F equals ma, and I have half m, that means I'm going to have twice the acceleration given the same force. So if I have twice the acceleration, v is equal to a times t. If I double my acceleration, I double my velocity. So 17 is A. Put your book on the bus seat next to you. When the bus stops suddenly, the book slides forward off the seat. Why? It's because no net force acted on it. It continued on in its state of motion as set forth by Newton's first law. Block of mass 2 kilograms moves on a flat surface. It has 10 newtons that cause it to accelerate at 2 meters per second squared. What is the coefficient of kinetic friction? So I have a 10 newton force in this direction. I have some kinetic friction in this direction. I don't know what it is, but I know that the net acceleration is equal to 2 meters per second squared. So I say the sum of the forces equals ma. 10 minus fk is equal to mass times acceleration. That's 2 times 2. So Fk equals 10 minus 4, or 6 newtons. Then I say, well, Fk is equal to mu times the normal force. F mu then is Fk over Fn, which is 6, divided by the normal force, which is going to be equal to the weight. I have the weight and then I have the normal force, so it's going to be over 20. 6 divided by 20 is 0.3, so E is 19. Woman who weighs 700 newtons steps on a scale is in an elevator, then the elevator begins to accelerate, and now she weighs 500 newtons. Okay, so first of all, since she weighs less now that the elevator is moving, I know that it can't be upward, so it has to be one of these others, A, B, or D. Let's draw my force diagram. I have my normal force, that's what the scale reads, and then I have the weight. And that's all that I have. So I have Fn minus Fw equals to ma. The woman now weighs 500 newtons. That means my normal force is 500 newtons minus the weight. Her weight is actually 700 newtons. And then that's equal to 70 kilograms times A. 70 kilograms because she has an actual weight of 700 newtons. So 700 equals m times g. So m equals 700 divided by g, which is 10, which is 70 kilograms. So this gives me A is negative 200 divided by 70, which is 2.9 downward. It's negative, so it's downward. How much tension is required to lift a 1,000 kilogram elevator upward with an acceleration of 2 meters per second squared? Very similar here. Here's my elevator, here's my force, here's my weight. F minus Fw equals the mass, which is 1,000 times 2. So F equals Fw, which is 10,000 newtons plus 2,000 newtons. That's equal to 12,000 newtons. So let's see, all these need an extra 0 on them. Sorry about that. A is the right answer. I'll fix that for your test. All right, 20 kilogram object moves from left to right at a speed of 3 kilometers per hour. What net force is required to keep this object moving at a straight line and a constant speed? Constant speed, so 0 newtons. 200 kilogram boat moves through the water with 2 forces acting on it. One is a 1,000 newton forward push, 1,000 newtons, 600 newton resistive force. That means that my net force is equal to 400 newtons, 1,000 minus 600, and this is going to equal to ma. So A is 400 divided by m, which is 200. So that's 2 meters per second squared. in 10 seconds, what is its velocity? Well, v is equal to v naught plus at. V naught is 0 because it's at rest, so it's going to be 2 times, what's my time? 10 seconds, 20 meters per second. So the boat is now traveling at 20 meters per second. All right, which of these equations is correct? Well, let's just draw our equations. I'm going to go ahead and I'll label them first. Fn, it has kinetic friction. It's moving down the inclined plane, so that's Fk. Oh, it's accelerating down the inclined plane. And then I have Fw, and this angle is 30 degrees. I'm going to draw these now over here, and I will resolve them into their vectors. This is Fn, Fk, Fw sine of 30, Fw cosine 30. Okay, so now let's look at this. Fn minus Fw sine of 60 is equal to 0. That's not true. It should be sine of 30. Minus Fk minus Fw cosine 30 equals max. It could be right if it were Fw cosine 30 minus Fk. That's not correct. Fn minus Fw, that's not true either. It should be Fw sine 30. So it looks like E is the right answer for 24. Okay, now the last one. These were 3 problems. In this figure, a block has a mass of 1 kilogram and sits on an inclined plane with 30 degrees. So this is 30. Let's go ahead, no friction. What is the acceleration? Let's go ahead and draw all of our force vectors. Fw, there's no friction, so Fn. That's it. So it's just those 2 forces. And now we'll draw Fn. Remember, this angle right here is 60 degrees. So I have Fw cosine 60, Fw sine 60. Okay, so let's keep that. But right now, really all I'm worried about is the acceleration down the inclined plane. So I'm just looking at the sum of the forces in the x direction is equal to max. And that's going to be Fw cosine 60. Actually, it's negative Fw cosine 60 is equal to my mass, which is 1 kilogram, times the acceleration in the x direction. So ax equals 10 cosine 60. Negative of that, that's equal to negative 5 meters per second squared. So looking for the magnitude, it's down the inclined plane, it's 5 meters per second squared. Now, what if I have a kinetic friction? What is the acceleration? So I'm going to add in a force here, my kinetic friction, and then over here, I'll add in kinetic friction here. First thing I need to do is figure out what is the kinetic friction. In order to do that, I have to find Fn. All right, Fn is equal to Fw sine of 60. Let me just take a little step back. What I did there is I said the sum of the forces in the y is equal to 0. That means Fn minus Fw sine 60 equals 0. But for an inclined plane, this is always true, at least for you guys, unless you have some other forces that are acting on it. And that'll always be the case for y'all. So Fn is equal to Fw sine 60. That's going to be equal to 10 times the sine of 60, which is 8.7 newtons, or 8.66 newtons. So that's my normal force. And then Fk is equal to mu k times my normal force, 0.12 times 8.7, I get 1 newton. So my frictional force is 1 newton, and now I want to know the acceleration. So I say the sum of the forces in the x direction equals max. That is Fk minus Fw cosine 60 equals max. Fk is 1 newton minus Fw cosine 60, that's 5 newtons, equals, what's my mass? 1 kilogram times the acceleration. So the acceleration is minus 4 meters per second squared. or D is 26. And then finally, what is the normal force? Well, let's see, I've already found the normal force, right? It's right here, 8.79 newtons. So 27 is C. All right, that's all.